Ionic bonds. Ionic bonds are bonds between metals and nonmetals. In ionic bonds, metals lose an electron, and nonmetals gain an electron. Remember that in ionic bonds, electrons are not shared, they are taken. Metal ions give away electrons, which make them positive. That is why metal ions are also called cations, because they're positive. Nonmetal ions take in electrons and are negative. Nonmetal ions are also called anions, which you can remember by thinking a negative ion. Some examples of metal ions are sodium and magnesium. Some examples of nonmetal ions are chlorine and oxygen. Let's look at NaCl, or sodium chloride. Na is the metal ion with a +1 charge. Cl is the nonmetal ion with a -1 charge. If we look at the valence electrons of each ion, sodium has 1 valence electron and chlorine has 7 valence electrons. Because chlorine is more electronegative, the electron from the sodium ion moves to the chlorine ion. Once the electron is taken by the chlorine, that is how an ionic bond is made. Metallic bonds. In metallic bonds, metal ions are surrounded by free-flowing electrons. The free-flowing electrons are also called a sea of electrons. As mentioned before, when talking about ionic bonds, in metallic bonds, there's a sea of electrons because metals have a tendency to lose electrons. That is why they are also called cations, because they are positive. Some properties of metals are that they are malleable, which means they can be shaped into sheets or different forms. They're ductile, which means they can be made into wire, and they're conductive, which means they allow the flow of electrons. These properties are all possible because metals have metallic bonds, which means there are free-flowing electrons between the ions, making them easily moved and making them conductive.
Next, we're going to talk about covalent bonding. So there are 3 types of covalent bonds. We have nonpolar, polar, and network covalent bonds. In a covalent bond, all the electrons are shared. Covalent bonds also only occur between nonmetal substances. So in this instance, we can imagine that 2 nonmetals are sharing their electrons. Let's look at nonpolar covalent bonding. In this instance, the electrons are shared equally. For example, this happens in O2, oxygen, and CH4. So if we look at O2, O2 is made out of 2 oxygen atoms, so that means they have the same electronegativity, which means they're pulling on each other with the same amount of force. That's why the electrons are all shared equally. Now we look at CH4. There are 2 different types of elements here, carbon and hydrogen. However, the central carbon atom is pulled in 4 different directions by the same hydrogen atoms, which means that it's getting pulled in different directions but by the same amount. So the forces exerted on the carbon are still equal. So next we're going to look at polar covalent bonding. This means that the electrons are not equally shared. For example, this happens in HCl. So in HCl, the chlorine is much more electronegative than the hydrogen, which means that it will pull on the hydrogen strongly. This means that the hydrogen will have a partially positive charge and the chlorine will have a partially negative charge. The last type of covalent bonding is known as network covalent bonding. So in these structures, they have 3D shapes and there are a lot of covalent bonds that connect the structures to each other. Let's look at some examples. So here we have graphite, diamond, and silicon. These are some well-known network covalent structures that you should probably memorize, and they, as you can see, they all come in 3D shapes. Network covalent bonds are incredibly strong because the atoms are bonded together by covalent bonds throughout the structure. So in order to melt a network covalent solid, all these covalent bonds must be broken. A network covalent bond is like a continuous network that extends throughout the solid.
Let's practice. First, identify the bond type of each compound. I'll give you a second to take a guess. Or pause the video and answer the question. Time for answers. The first answer is ionic. This is because there's one metal ion and one non-metal ion. The metal ion in this case is sodium, Na+. The non-metal ion in this case is chlorine, Cl-. The second answer is nonpolar covalent. You can find this out when you draw the Lewis dot structure of CH4. The shape is tetrahedral, which is symmetrical. You can learn more by learning about Lewis dot structures and shape names. The third answer for H2O is polar covalent. This is because H2O is only made of nonmetals, and the shape of H2O, when the Lewis dot structure is made, is asymmetrical. This is because carbon is a nonmetal, and the repeated structure of carbons bonded together creates a network.